All right, good morning, class, and happy Friday. Today, I know we talked about this yesterday, but today we're going to go ahead and start talking about polygons, and then also start talking about special types of quadrilaterals. Okay, so first of all, what is a polygon? Well, a polygon has to pass two different rules. One is that the symbol is made up only of straight line segments. Okay, so let's take a look and decide which ones are only made up of straight line segments. And I'm going to go ahead and box this in purple. So a squall is, lightning, cumulus cloud would not be because there's a curved, and then we have snow, don't know how to pronounce that type of cloud, hail, and showers. Okay, haze and tropical storm would not work due to the fact that they're both curved. So test one is that they have to have straight line segments. Okay, and then the other part of polygons is that each segment can exactly only intersect at exactly two other line segments, no more. Okay, so basically one at each endpoint. So I can't have like a line and then intersect it 3 different times. Okay, so let's go through. A squall would work, and I'm going to circle these ones. Okay, lightning would actually not work because it has to be exactly 2, and if you look, this segment only intersects at 1 point. So that doesn't work. Snow doesn't work, the cloud doesn't work, hail does, and so do showers. Okay, so squall, hail, and showers would be oh, sorry, I think I just wrote this in the wrong place. So squall, hail, and showers are the only polygons we have. Okay, so what do you think is the fewest number of sides a polygon can have? Well, if we look at lightning, that one only had 2, and we weren't able to connect it to make a polygon. If you look at showers, we had 3, and we could make a polygon. So this would be 3. And then what is the greatest number of sides of a polygon can have? There's no max. We can keep making as many as we would like. Okay. So in conclusion, a polygon is a figure with 3 or more sides, and the line segments must be straight, and each side must intersect exactly twice with the other side. Okay, so go ahead and you guys are going to circle under the programming symbols, sorry, and pause the video and then go ahead and figure out which ones are polygons. Okay, so by now we should have paused it and did the problems. So we should have gotten process, manual operation, input, output, decision, and extract. So document, online storage, and connector all had a curved line, or curved segment, I mean, and the collate intersected at 3 times, 1, 2, and 3. All right, let's go to the next page. Polygons are named by their sides. Okay, and the 2 that we're going to focus on, well, actually, we've already been focusing on a triangle, but the one we're going to add on today is a quadrilateral. Okay, so a 3-sided polygon is a quadrilateral. A 4-sided polygon, a 3-sided polygon is a triangle. A 4-sided polygon is a quadrilateral. I was thinking before I was writing. Okay, and then the other part of polygons we need to know is that diagonals of a polygon are segments that connect any two non-consecutive, that's really important, non-adjacent vertices. So if you look at the highlighter up here, I can't go adjacent, so I can't go right next to. So a diagonal has to go to an opposite vertex that's not right next to it. Okay, so let's say we take a triangle. How many diagonals does a triangle have? Okay. Hopefully you said 0, because if I start at this vertex, okay, I cannot go to any other vertex that's not adjacent to it. Okay, there's no other options. So a triangle has 0 diagonals. That would be a good active note to take. Okay, a triangle has 0 diagonals. All right, the next thing we're going to talk about is concavity, concave or convex. So if all diagonals are inside the polygon and all interior angles are less than 180 degrees, then the polygon is convex. Okay? It doesn't mean that the sum of the angles are less than 180. It means that each individual angle is less than 180. Okay? And then if at least one of the diagonals is not inside the polygon, or an interior angle is greater than 180, then the polygon is concave. Okay? So if you look at the examples, think of perfect picture here, but I always remembered concavity as like a bear going to hibernate, going into its cave. Okay? So if we look at the first example, anywhere I draw a diagonal, they all stay inside the polygon. Okay? And nothing caves in. So this would be an example of a convex polygon. Okay? In the middle example, if I were to connect this point to that vertex, or even this vertex, we have a diagonal that's not in the polygon. Plus, it's concaved in, like we're going inside the polygon. So this is concave. Okay. And then the next example is kind of a trick question, because most likely you probably thought, oh, it's concave, it's going inside. However, this is not a polygon to begin with. So we can't say if it's a concave or convex polygon because it's not a polygon. Okay. All right, so how do we name a polygon? Basically, you start at one vertex and then you proceed either clockwise or counterclockwise. It doesn't matter which one you start with. It doesn't matter if you go clockwise or counterclockwise. You just can't jump ship. So you can't go from, like, let's say, A to E to C to F to D to B. Okay, it has to go in order. So typically you just start with A, B, oh, sorry, hold on one second. There's no commas in between. So A, B, C, D, E, F would be the name of this polygon. Okay, so I could have started at F and gone F, A, B, C, D, E. Doesn't matter. It just has to, you can't jump ship around. Okay. In the second example, if we were to go to name this polygon, then we would have a problem because this is not a polygon. I forgot A. So it's not a polygon. Notice that this segment would intersect at 3 times. Okay. In this example right here, it's kind of tough because I could see you guys thinking, well, wait a minute, there's 2 of them in here. So we could say polygon KPOM, we could say PRO, or we could say KPROM. Okay. And then the last one is kind of tricky because you would just say SYTV. You would not include the X because it's not a vertex. So you only include letters that are vertices. Okay. All right, let's go ahead and go to the next page. If you need to write an active note about it, you can only use the letters that are on the vertices, that's fine. Remember, you guys can pause at any time that you need to. Okay. All right, let's talk about a quadrilateral. So the sum of the measures of the interior angles of a quadrilateral is 360 degrees. Okay. In a quadrilateral, a diagonal divides the figure into two triangles. Okay. So here we have triangle ABD, and we have triangle BDC. Okay. So if we take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, that's going to equal 180 degrees, because remember from yesterday, the interior angles of a triangle add up to 180 degrees. And then 4, 5, and 6 would also equal 180 degrees. So a quadrilateral is made up of two triangles, and if the two triangles are 180 degrees, then the sum of all six, all six angles, 360 degrees. I see what that says. Okay. And those little dots, by the way, mean therefore. So therefore, the sum of all six angles is 360 degrees. All right, let's go ahead and try these problems out. So as a reminder, how many angles are in a quadrilateral? Quad 4. Okay, so when you guys are doing these problems, you should make sure that you are always adding up 4 angles. So let's go ahead and take a look at example A. So we have x plus 113 plus 98 plus 42 equals 360. So notice how I put 4 sets of parentheses to mimic the fact that we have 4 angles. Okay, so now go ahead and add these up. And we should get x plus 253 equals 360 degrees. And then subtract the 253, and we should get 107 degrees. Okay. All right. Go ahead and pause the video. Let's try B on our own and share with our partners. So hit pause now. All right, here's what we should have gotten. X equal 30. Okay. Be careful. You had to make sure that you added up 4 angles. Okay, so 1, 2, 3, 4, and these 2 angles both represent 90 degrees. Okay, all right. Let's go ahead now and start talking about quadrilaterals. All right, so a quadrilateral is a 4-sided polygon, which we've talked about a few times, but we're going to focus a lot on special quadrilaterals. And there's a lot of properties, and this is kind of why I was telling you guys yesterday that we need to make this booklet, because we need to have all these properties memorized. Some of them do repeat though, so don't completely freak out about how much you have to memorize. So a parallelogram. So a parallelogram, opposite sides are parallel, hence why it's called a parallelogram. Okay. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Okay. And the last one is diagonals bisect each other. So you definitely need to learn these first 5 because each parallelogram contains these 5 properties and then some more. So it's important to know the framework of what a parallelogram is. So we're going to spend more time on Monday on the actual diagrams, but this is just an example of what a parallelogram would look like. So opposite sides are parallel. Okay. Then opposite sides are congruent. Opposite angles are congruent. And we'll worry about diagonals later, as well as the consecutive angles being supplementary. So I just wanted to give you guys a diagram of what it looks like. All right. So rectangle, and when you do your booklet, you're still going to list all of these out, so all 5 properties, but for our notes purposes today, we're just going to say properties of a parallelogram. Okay, that's shorthand for parallelogram. But once again, when you do your booklet, you're going to list out all 5 first. Then, property 6 would be diagonals are congruent. And property 7 is going to be all angles equal 90 degrees. Okay, all right, next up, just kidding, not a kite, missed the rhombus. All right, so back to the rhombus. We are going to do all properties of a parallelogram, so you're going to list those 5 first. Okay. And then to add on, property 6 is diagonals are perpendicular. All sides are congruent. And diagonals bisect opposite angles. Okay. So a rhombus is another example of a parallelogram. It just has more properties, more details. Okay. All right, now let's go to the kite. By the way, the order of your notes is almost the order of your booklet. So kite and... Okay, so a kite actually is not a parallelogram. Okay. But the properties for a parallelogram are 2 pairs of consecutive sides are congruent. Another way you might hear this is disjointed sides are congruent, which once again we'll explain more about the diagrams on Monday. So diagonals are perpendicular. One pair of opposite angles congruent. Only one pair, not both. Okay. One diagonal is the perpendicular bisector of the other. And then one diagonal bisects a pair of opposite angles. So if you need to stop the video to write these all down, please go ahead and do so. But these are the properties for a kite. Remember that a kite is not a parallelogram. All right. So now on to a square. Okay. So a square is going to be all the properties of a parallelogram. Okay. And then we have diagonals are perpendicular. And diagonals bisect opposite angles. Okay. And all sides are congruent. This comes from the rhombus. So a square is a rhombus. But there's properties of a rectangle that are also a square. So from the rectangle, the diagonals are congruent, and all angles equal 90 degrees. So these properties come from the rectangle, but the square contains all of these properties. So you're going to want to write all of them down in your booklet. Okay. As you guys can start to see, the properties can get a little overwhelming, which is why we're making this booklet. All right, trapezoid, not bad. Property 1, there's one pair of parallel sides, which means it's not a parallelogram. And 2, upper base, which we'll talk more about this later, and lower base are supplementary. Or you might hear consecutive angles are supplementary, same thing, but trapezoid is not a parallelogram. Okay. And then isosceles trapezoid is a special type of a trapezoid. So first it has the two properties. Sorry, I don't know where it stopped and where it did not, so I accidentally hit pause. So hopefully you guys have the properties for a trapezoid. The isosceles trapezoid is a special type of trapezoid. It first contains the properties above, though. And then the new ones are the legs are congruent, diagonals are congruent, the base angles are congruent, and opposite angles are supplementary. Not consecutive. Opposite angles are supplementary. So lots of properties. I just want you guys to get these down in your book today. On Monday, we will start drawing the pictures of them, and then we will start using these properties more. One thing about your homework tonight, we still have to do these examples down here, but one thing, number 7 on your homework is a probability question. All you need to do is list all that are true. For tonight's homework, number 7, don't worry about doing the probability, just list the ones that make the statement true, like what quadrilaterals make the statement true. Okay. All right, last thing up. These are the fun questions. You guys are going to love them. Okay, probably not. But anyways, sorry, I'm getting a little slap happy making this video if you can't tell already. All right, a square is a rhombus. Okay? A square contains all the properties of a rhombus. Okay, so this is always going to be true. However, not each rhombus is a square. It is possible to be a rhombus, so all sides congruent, diagonals are perpendicular, but not have all angles be right angles. So a rhombus is only sometimes a square. Okay. We will have a nice little visual diagram we're going to fill in on Monday that'll help you with that statement as well. So a kite is a parallelogram. Hopefully you all know that this answer is never. Great. A rectangle is a polygon. Once again, hopefully we know that this is always true. A polygon has the same number of vertices and sides. Well, let's think about this. A triangle has 3 sides and 3 vertices. A quadrilateral has 4 sides, 4 vertices. So what do you think the answer is? Fantastic. It is always. Okay. A parallelogram has 3 diagonals. Well, let's draw a parallelogram. 1 and 2. Remember that I cannot draw to consecutive sides, so this is never true. A trapezoid has 3 bases. False. It only has 2. A parallelogram is a rhombus. It's true that a rhombus is a parallelogram, but a parallelogram doesn't have to be a rhombus. It could be a rectangle if it wanted to be. So this is only sometimes. Number 9, a circle is a polygon. That would be never because it doesn't have straight segments. And then a polygon is a triangle. This is sometimes. Yes, a triangle is always a polygon, but a polygon could also be a square, a rectangle, a rhombus, and so forth. Okay? So I'm sure this probably just boggled some of your minds just right now. So remember that the only thing you really need to focus on is filling out your booklet and then also doing your homework, which actually has more examples like for solving, and then just a couple questions on true and false. Okay, so now it's time to make your booklet. I'm sure you're sick and tired of hearing me talking. Then you guys can have the rest of the time to work on the homework. So please have a wonderful and safe weekend. Please be awesome for our sub, and I will see you guys on Monday. Over and out.